It's great to be giving this talk. This is a great webinar series. I think the QUT group, a lot of the Theme 3 group are quite new to the Antarctic space. And so I hope this is the start of some really good conversations about the work that we could all do together. I'm going to give a brief overview of what Theme 3 does, what its sort of key elements are. And then I'm going to hand over to first Kate Helmstead and then to Matthew Adams, who are going to talk a bit more about the sort of specific work that we do and that they've done and how that might connect to SAEF and to Antarctic research in general. So SAEF's going to do some profound, groundbreaking environmental research in Antarctica. And that's going to be the foundation and I guess like a lot of the powerhouse of how we make a difference to Antarctic conservation. And that's normally focused on understanding the environment, gathering data on it, constructing and testing theories about it, the sort of learning elements of science. And Theme 3 is not going to focus specifically on those elements, not directly. We're more interested in the parts of stewardship, of conservation in Antarctica that sit above the environment and the data and the theory. And we hope to make contributions to this overarching set of structures in a series of different ways. And so above those data and theory, above the environment are a series of decisions that we have to make about where we act and how we act and when we act. And that's obviously been a real focus of sort of environmental decision theory in Australia and around the world over the past couple of decades. And then above that, and this is particularly important as Stephen alluded to, there are management organizations. There's the actors that are making those decisions and are enacting those decisions. And there are the processes that these organizations go through and the structure of that sector that affect what decisions are made, how those decisions are made, how effective they are. And so Theme 3 wants to sort of have a crack at all these different elements in the Antarctic space. So we're interested in the relationship between decisions, data, and the environment that's commonly thought of as adaptive management. And we have an interest in what's called value of information theory, which is a sort of variant of adaptive management that helps us understand what data needs to be gathered to make good decisions. We're interested in how to make those complicated, particularly spatial decisions more effective using the tools of conservation planning and systematic conservation planning. And we've got some deep expertise in that field in Australia, clearly, and within this group. And then, and this is, I think, going to be a really novel contribution to the Antarctic stewardship space, but also to environmental stewardship more broadly around the world. We're going to think really strategically about how management organizations operate in Antarctica and how the structure and the nature of those interactions and behaviors change what we do using a series of techniques from strategic analyses that come out of politics and game theory and mathematics. And, you know, because this is a lunchtime talk and because I'm a naturally pretentious person, I want to try and go about talking about the 3 key elements of what Theme 3 will do with an unnecessarily obscure statement about 3 pieces of art. I do believe as a mathematician that, you know, the quickest and easiest way to profundity is through obscurity. And so now hopefully I'll trick you into thinking that I actually know what I'm talking about by some first-year art history. Now, so value information theory, which is like a very specific way of talking about what do we need to know about Antarctica, is really important because the continent is remote and forbidding and risky and expensive and highly constrained. And so we don't know much about it and we need to know more about it, but it's very hard to know more about it. And so value information theory is a way of deciding what bits we need to understand first and foremost. And so it's an answer to this question. To make the right decisions, what ecosystem elements are going to require additional research? And that's a really hard question to answer because there are very many things that might help us make decisions and we don't know much about any of them. And so let's think just briefly about this piece by M.C. Escher, an artist beloved of mathematicians. It's Metamorphosis 2. It's part of a series of wood prints he made that sort of explored the idea of positive space and detail in art and negative space in art. And Escher's idea, and I think it's a really important one, is that we can communicate a lot through the space between detail. And he was always bringing out detail within that space to try and draw your attention to it when it's simply negative space. And negative space has a way of sharpening our focus on positive space. And it also has a sort of subconscious and subliminal way of communicating with us. And that's like the real essence of value of information theory, because normally we think of the question, what do we need to know? But value of information theory, I think, asks instead, what don't we need to know? It tries to answer the obverse of the question to really focus our attention on the first part. And to give you a brief example, imagine that we had a single species that existed in two ecosystems. And this is some work by Otto Oveskainen, the model behind this figure. It predicts the mean time to extinction of a stochastically varying population that has a particular intrinsic growth rate, shown on the x-axis, and a sort of particular population size, a carrying capacity on the y-axis. Now the red areas are a long time to extinction, the blue areas are a short time to extinction. And imagine there's like one place in the landscape, the red place, where we don't understand the species very well. We think it's got a high growth rate but a low abundance, but we're not quite sure. And there's this second place, this black ecosystem, where we know a bit more about the species. We know about its growth rate. We know about its habitat extent. And so this would normally tell us, if we think about the detail, what do we know, that we should focus our attention on learning more about the red space because it's the more uncertain one. And the black ecosystem is better understood already, so let's not focus on that. But value of information theory says, well, behind the information, behind the understanding of the system sits a decision. And we have to look through the mean time to extinction, which is, I guess, something we can know, to the decision that we would make depending on where we are in this space, which is what we would do. And when we think about it that way, and we think there are two options available to us, we can improve the quality of the habitat, and that's in the blue space, or we can increase the species growth rate, which is in the red space. And suddenly we realize that the red ecosystem, uncertain though it is, lies entirely in the space where we care most about the habitat. And the black ecosystem, despite the fact that we know more about the species there, is on the interface between the two decisions. And so when it comes to the question about what we should do rather than what we need to know, what we already know, the answer is not as simple as where is the most uncertainty. It's more a question of what decision are we trying to make and where does our uncertainty place us in that decision space. And clearly for different decisions, we would have a different decision landscape, despite the fact that the left-hand graph would remain the same. And so our attitude towards uncertainty is a reflection of the decisions that we need to make that hide behind it. Now, the second area we're going to think about in theme 3 is protected area planning, conservation planning in general, but particularly with a focus on, at first, the system of Antarctic special protected areas and special managed areas that deliver on-ground conservation in a really concrete way. Now, protected areas are clearly central elements of biodiversity conservation worldwide, and that's true in Antarctica, but unfortunately, as Justine will tell you in her amazing paper in PLOS Biology, they're relatively inadequate. And that's not just inadequate, they're, to read the title, both unrepresentative and at risk as well. And so we would like to develop a series of tools and adapt existing tools to fit the Antarctic problem that help us deal with some of the real challenges in the Antarctic that are additional to these inadequacies, unrepresentative nature, and risky protected areas that we have now. So we want to focus on challenges like connectivity and its interaction with climate change, which is obviously going to be a problem in polar regions. We had a great talk last week about how the interface between glaciers on the land and the bathymetry of the coastal environment has a serious impact on coastal biodiversity. And so there's some great extensions we can make of classic conservation planning tools that might help us take advantage of or work with those interactions. And that's a space of great sort of discovery at the moment all around the sort of conservation planning world. And finally, and perhaps most interestingly in Antarctica, is the fact that there are these multiple actors that are at play in Antarctic conservation, Antarctic decision making. And one thing that they, oh boy, I've lost oh yeah, no, I've got another piece of art. Right, there's a problem with that because it means that when a proposal is made for a new protected area, it takes some time for that to become a real protected area. And there's this gap between the sketch of the protected area system. You can see here on the left-hand side, this is Frank Gehry's plan for and then realized Guggenheim Museum in Bilbao, Spain. One of the great architectural delights of the 1980s and onwards. And you can see how far it is between what he originally sketched for the frontage of this art piece and its final realization. And that matters for conservation planning as well. And at the moment, the tools that we have for designing protected areas don't take into account this process that it goes through to get on the ground. So on the right-hand side here, you can see three figures that are focused on the central part of the Great Barrier Reef between Rockhampton and Mackay. And in 2001 at the top, you can see the proposals made by the application of a tool called MarkSan to think about where the best locations for reef protection in this area would be. The goal is here to produce comprehensive, adequate, representative, and efficient reserve systems. Now these were, fiddled around a bit and put into a proposal in 2002 by Gabrumpa. So changes have already been made to the outputs of this software. And those proposals were turned into a real protected area system, the one we have now, by 2004, after socio-political processes were laid on top of those changes. And the difference between the planning model and the enacted varies between about 5 and 20%, depending on where you look in the Great Barrier Reef. And that has an enormous impact on the ability of that protected area network to deliver the goals that it was designed to deliver. There's a long journey between the plan and the action, and that's particularly true in Antarctica. And so we need to develop the tools that we have to understand and prepare for and harden our plans for these inevitable changes that are going to happen. And in doing so will require us to understand not just the biodiversity and its distribution in Antarctica, but the process of designation itself, the specific process in Antarctica and how that might affect outcomes. And that leads on to the third part, right? Because what we're asking you to do here is what medieval and Renaissance church builders were doing too. They were taking the eyes of the parishioners from the ground beneath their feet to look upwards at the heavens and to see the sort of gods and the beauty that's above them. And that's what we're trying to do here with this third element, this strategic analysis. Above the sort of the biodiversity, there's the actors. And that comes into protected area planning the way I just described, but it comes into all elements of conservation. And the diversity and the structure of organizations who undertake conservation is almost as beautiful as the biodiversity itself, and certainly obeys many of the same laws and processes of a competitive ecosystem that we would see in the natural environment. And so Antarctic stewardship requires consensus. And consensus is a very particular form of decision-making. And until we understand that, until we grapple with that in a really assertive way, we're going to have trouble making proposals that are any use, let alone if they were enacted, whether they would be effective. And to give you one brief example here of how strategic analyses can make us think differently about decisions. If we had 10 actors in this place sitting around a table making yes or no votes on particular proposals, then to achieve consensus, we need to design a proposal that fits with their different objectives. And doing so for a single issue vote is often impossible. There's no space in the multidimensional vector space of their objectives where a particular proposal matches them all enough to say yes. But one thing we know from classic game theory is if we couple our single issue to a second issue and we start to horse trade amongst these decisions, then suddenly finding a set of decisions that can make everybody get to the point of yes is much, much easier. And the more issues we couple, the higher the likelihood, but the greater the transaction costs. And so thinking about this particular interaction is something that we need to learn about at the same time as we enact. And so I'm going to hand over now to Kate Helmstead, who's going to talk to you a bit more about her work, and then she'll, without my further intervention, pass on to Matt Adams. Thanks.